All right, let's dive right into this explainer. Today, we are tackling a massive, literally billion-dollar question. Can AI actually conduct its own open-ended scientific research? We hear a ton about artificial intelligence passing bar exams or writing incredibly complex code. But the ultimate holy grail for the AI industry, it's an agent that can act as a fully autonomous scientist, one that can make brand new discoveries and essentially build the next generation of AI all by itself.
Now, you've probably seen these explosive claims from the major labs suggesting that AI is right on the verge of automating its own research and development. In June 2026, Anthropic literally published a post titled, "When AI Builds Itself." And then just a month later, in July, OpenAI advertised that their new model, GPT 5.6 Sol, had actually helped post-train a smaller model. They claimed this saved human researchers multiple weeks of effort. So the premise being pushed by these leading developers is that explosive, exponential AI progress is right around the corner, mainly because AI systems will soon be doing the heavy lifting of AI research themselves. But here is the real question we need to answer. Can today's frontier AI agents actually do this? Can they conduct open-ended, publishable scientific research completely on their own? See, most of the prior evaluations that labs used to boast about their AI's research capabilities rely on really narrow, verifiable tasks. We're talking about things with a fixed metric, like winning a Kaggle competition or optimizing a very specific piece of code. But real science? It isn't just about hill climbing a known metric. It involves choosing hypotheses, recognizing when an approach is totally dead, and employing deep, creative problem solving. So we are going to put those massive claims to the test today and look at the hard evidence. Here is our roadmap for the explainer. First, the promise of automated AI. Second, testing AI in the shadows. Third, why these models are brilliant engineers but terrible scientists. Fourth, the 5 critical failure modes. And finally, number 5, the future of AI research. Let's get right into it. Section 1, the promise of automated AI. Let's establish exactly what is being tested here. It's kind of like a giant puzzle. If we want to know if AI can do true open-ended research, we obviously can't give it a test where the answer is already sitting out there on the internet. Why? Because the AI might have just memorized it during training. We need something completely novel. To figure this out, a landmark study from July 2026 by the Crux Core team, which includes top researchers from Princeton, Berkeley, and other institutions, asked a very plain question. Can AI agents conduct open-ended AI research? Now, just submitting AI-generated papers to regular blind peer review is pretty flawed. Human reviewers are overstretched, and the whole process is a bit stochastic anyway. So this team introduced a totally new third way to measure progress, which forms the foundation of our entire explainer today. Moving on to Section 2, testing AI in the shadows. The methodology they used here is absolutely genius. They utilize something called a shadow evaluation. Think of this as the ultimate blind taste test, or maybe a parallel universe, where the AI has to solve a mystery without ever being able to peek at the answer key. The researchers took high-quality research papers that had been submitted to the NeurIPS 2026 conference, but crucially, these papers were not yet public. Because they weren't public, the AI couldn't possibly have the answers hiding in its training data. The AI was given the exact same central research question that the human authors started with. Then, at the very end, those original human authors graded the AI's final paper as if they were official conference reviewers. And the setup was intense. The researchers unleashed Claude Opus 4.8, running on extra-high reasoning settings on 2 specific unpublished papers, the Personas paper and the TAB PFN paper. They gave the AI an absolute war chest to work with. We're talking a massive $3,000 API budget in Anthropic credits, full GPU compute budgets for running experiments, total access to a virtual machine, the open web, and a full 6 days of wall clock time. The goal was simple: produce a paper worthy of publication at a top-tier AI conference. Section 3, brilliant engineers, terrible scientists. The contrast in what the AI achieved versus where it completely failed is fascinating. First, we absolutely have to give credit where credit is due. The AI's engineering feats were phenomenal. It autonomously managed servers and wrote code perfectly without any human handholding. When things crashed, it successfully debugged complex Linux GPU environments. It ran hundreds of highly compute-intensive experiments all on its own. It autonomously searched the web for literature, seamlessly used external AI reviewing tools, and even compiled all its final results into a beautiful, camera-ready, properly formatted LaTeX PDF document. Basically, as an engineering lab assistant, it was virtually flawless. But as a lead scientist, well, that is a completely different story. Just take a look at the actual scientific output it generated. The initial draft for the personas research is just an impenetrable, blocky wall of text right from the abstract. And the tab PFN draft is just as rough. The human reviewers found these documents incredibly difficult to read. They noted that the AI buried any actual scientific findings under absolute mountains of qualifications, caveats, and bizarre methodological choices. The writing was so dense and poor that the human supervisors actually had to step in. They literally had to ask the AI to do a readability pass just so the documents could be properly evaluated by the judges. Now, even after the researchers intervened for that readability pass, which did successfully break the text into slightly more digestible paragraphs and add proper headings, the underlying science remained a total mess. The agents falsified their own hypotheses using tiny, hand-curated or synthetic datasets. Then they tried to pass off severely underpowered, negative results as substantive scientific findings. Unsurprisingly, both papers were unambiguously rejected by the human experts. Which brings us to Section 4, the 5 critical failure modes. Let's do the autopsy on exactly why this happened. You see, this wasn't just one random bug in the code. It was a systemic failure in scientific intuition. The researchers identified 5 distinct failure modes: poor judgment on research quality, uncreative problem solving, totally ineffective backtracking from dead ends, incredibly poor resource awareness, and instruction drift. Let's break down the data to see exactly how each of these failures played out during the 6-day experiment. Let's start by looking at the personas experiment, specifically regarding poor judgment and uncreative problem solving. Across 4 chronological rounds of the AI's internal self-review, the red weakness bars completely dominate the blue strength bars. It's scoring itself a 3 or 4 out of 10, strictly categorizing its own work as weak rejects. But here is the kicker. Instead of creatively rethinking its approach or pivoting based on its own negative feedback, the AI just stubbornly added caveats to a failing paper. As a result, the final review from human expert David Africa shows a massive red bar of 7 major weaknesses to only 2 strengths, resulting in a firm reject. He specifically noted the AI's choices were unprincipled and bizarre. The AI knew its paper was bad, but completely lacked the creative problem-solving ability to actually fix it.
We see the exact same stubbornness with the tab BFN paper. Look at the breakdown here. 10 consecutive rounds of internal self-review. The red weakness bars consistently hover around 10 to 18 per round, vastly outweighing any strengths. 10 times in a row, the AI told itself, this is a weak reject. Yet it didn't change its core approach. It just kept polishing a fundamentally flawed premise. Ultimately, human expert Vitin Nguyen handed down a devastating strong reject, listing 5 core weaknesses to just 1 strength. He called the AI out for using a highly unscientific proof-by-example fallacy to try and claim a negative result. To make matters worse, and highlighting the failure to backtrack from dead ends, the agents were actively misled by overly lenient external tools. During the process, the models consulted the Stanford Agentic Reviewer. This external AI reviewer incorrectly recommended an accept rating for both of these deeply flawed papers, flashing massive blue strength bars. We're talking up to 13 strengths in round 1 for tab PFN. Instead of recognizing a dead end, the agents took this hallucinated praise as permission to double down. They overweighted lenient feedback to justify sticking with broken ideas instead of starting over. Now let's talk about failure 4, incredibly poor resource awareness. The data tracking the personas agent's resource consumption over time is shocking. On the horizontal axis, you have hours elapsed, and on the vertical axis, the share of resources consumed. The green line represents wall clock time, the purple is GPU compute, and the red line at the bottom is the Anthropic API spend. If you trace that red line tracking the API budget, it hits just $1,130 out of a massive $3,000 budget, and then the line just goes completely flat. The agent essentially threw its hands up and quit just 5 hours into a 6-day timeline. It retired its headline finding after a single early test failed, leaving thousands of dollars and days of compute time entirely on the table. It completely lacked an intuitive grasp of long-term budgeting. The exact same catastrophic resource mismanagement happened with the tab PFN agent. Looking at its trajectory with time on the bottom and resources on the side, the red API budget line barely clears the 40% mark, topping out at just $1,235. The purple GPU compute line is practically non-existent, a measly $69 out of a $100 allowance. It stubbornly committed to a negative finding 40 hours early. Even when the human supervisors gave it a 24-hour extension to try and improve, it submitted its final draft with 60% of its budget totally untouched. And finally, failure number 5, instruction drift.
This comparison really nails the difference between a biological scientist and an artificial one. Unlike a human researcher who adapts, maximizes their available budget, and strictly respects conference guidelines, the AI suffered from what researchers call context window rot. By the end of the week, the model simply lost track of its initial constraints. It completely forgot the strict 9-page limit we gave it on day one, and it submitted a 10-page paper. In the real world, that paper would have been automatically tossed in the trash by human conference reviewers for a simple formatting violation. Finally, Section 5, the future of AI research. Let's pull this all together. So, what is the big takeaway you should have from this fascinating postmortem? What does this mean for all those breathless claims about automated self-improvement? Well, the reality check is this. Today's frontier models are unparalleled lab assistants. They are highly capable of heavy engineering, running scripts, and debugging servers. But they are terrible lead scientists. They lack the judgment to know what constitutes a substantive finding, they are prone to giving up way too early, and they will stubbornly double down on bad data instead of getting creative and starting from scratch. Which leaves us with this final, provocative thought to consider. This shadow evaluation essentially proves that just throwing massive context windows, thousands of dollars in API credits, and days of compute time at an LLM does not magically produce scientific intuition. So, what is the missing ingredient? What will it truly take to give artificial intelligence real scientific creativity and allow it to cross that chasm from lab assistant to lead researcher? That is the billion-dollar question the industry still needs to answer. Thanks for joining us on this explainer today. Keep questioning the hype, and we'll catch you next time.